What's up, you math nerds? Hope you're having a fabulous afternoon, evening, morning from wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and this is Tuesday's Integration B. As you already know, every Tuesday we hang out, we do some integrals, and on Thursday we do some math survival skills. I'm always here live on TikTok at least twice a week. Anyway, again, hope you're all doing well. I have some integrals that I want to review with y'all, some techniques. My brain has been all over the place. I've been working on like the integrals of tan, the cubic root of tan, root tan. I think last week a lot of people traumatized me with those types of problems. So it's been nice, and it's been busy, just inundated with integrals. Oh, that's awesome. Serbo Bear, bro, tag or go ahead and put what your wife's business is. Does she have a TikTok? Sorry about that. I had to move the lighting there. Oh, I think that looks way better. Yeah, the college pacing is difficult. It's just a matter of, again, just practicing. You got to just get in there and get a piece of paper, a pen, or a pencil, and just write as many problems as you can down and just practice, to be honest. All right, let's go ahead and start off with a basic integral that I had. I actually had this one. I believe this is it. I just posted this one on my TikTok. Not my TikTok, I'm sorry, my Instagram. I'm just going to double check that's the right one, and we can go ahead and get started. But just looking at it, if you have an idea of how we can solve that, go ahead and let me know in the chat. I'm just going to double check that's actually the one that I wrote. It's basically the same one, but I just put x to the fifth. But again, curious if you guys have any idea on how to solve this. How can we go ahead and integrate this? Pepsi fan, you're going to have to ask Layla if that's okay. I have no idea. Change to a negative exponent. That's interesting. I actually never thought about that method, but let's go ahead and write it out. Someone said partial fraction decomposition. Well, I'm going to go first with Vish said change to negative exponent. I'm assuming you mean this, 1 over x to the negative fifth minus 1 over x. Perhaps that. I know it's kind of hard to translate these things when it comes to like the typing stuff. But I'm not sure if that looks as nice as I want it to be, or maybe perhaps that's not what you were talking about. Partial fraction decomposition, that's actually one of the, it could work. First thing that I'm going to do, or first thing that I would suggest is if you have a problem like this, let's go ahead and factor out an x from the bottom. Because now we're going to have 1 over x times x to the fourth minus 1 dx. And from there, someone said trig sub. Check out what I'm about to do, okay? This is a really cool one. People always have two different ideas to solve this, but what I like to do is I'm going to go ahead and make that my u. I'm going to make that x to the fourth minus 1 my u, and I'm going to find my du, which is going to be 4x cubed dx. Now we're going to go ahead and divide the 4x cubed to the other side, and we get du over 4x cubed is equal to dx. So then now we can rewrite our integral. So now what we have is integral of 1 over x times x to the fourth minus 1, which was our u, times our dx, which is now the du over 4x cubed. Now check out what's going to happen. I'm going to be able to, 1, move the 4 on the outside. It's going to become a 1/4. And I'm going to go ahead and multiply the x and the x cubed. So now I have du over 4x to the fourth times u. Not 4x to the fourth, I'm sorry, just x to the fourth times u. And now this is going to prove helpful because look up on top. We have that x to the fourth minus 1. So we can move the 1 to the other side and get u plus 1 is equal to x to the fourth. So we can go ahead and substitute that u plus 1 in for this. And so now we have 1/4 integral of du over u plus 1 times u. Meyer, this could be a difficult integral for some people. I do have a couple that I do want to do, but again, the more difficult they get, the less people are viewing, and I don't feel like it's that helpful. But if you have one, drop it on here or drop it in the Discord, and we'll definitely try to practice that. So now look at what we have. This was going to be a partial decomposition that Gumo had mentioned. Now we're going to have a partial fraction decomposition. And this is going to become 1/4 integral of, I believe we could just do u over u minus u over u plus 1 du. This is just a neat trick. If you were to kind of work this out and try to combine this using common denominators, you will get that this 1 over u minus 1 over u plus 1 is equal to that integral here. So it is partial fraction decomposition, but it's one that you can kind of memorize and just mess around with. Because now what we have is we have the integral of that first part, which is going to be 1/4 natural log of u minus 1/4 the integral of that, which is natural log of u plus 1 plus c. And now we just have one last step to do, and that is to go ahead and plug in the values of u that we found back into there. So I'm going to go ahead and make this smaller. If you've been on this live before, you already know that we're always making space here on the blackboard. So now we have 1/4 natural log of, what was our u? It was x to the 4th minus 1. So we have x to the 4th minus 1 minus 1/4 integral of, or natural log, absolute value of x to the 4th minus 1 plus 1 plus c. And you can go ahead and simplify this. This cancels out, and you could rewrite this if you wanted to, but that is going to be our answer. Sky, today we are doing simply integrals. It is Integral Tuesday. Oh, Saul came in and said, or Sai, I'm sorry, do the integral of 1 over square root of tan x. Why not? Let's go ahead and try that one out. 1 over the integral of square root of tan x. I'm going to be honest. We might get stuck on this problem. Definitely last week when we were doing just a square root of tan x, we had some difficulty with it, but we got around it. And I posted a nice video on that. I think I made a couple posts about the integral of root tan x. Okay, so now that we have this, any suggestions? What should we do? Let me know in the comments or in the chat what you guys would suggest we try to do 1 over root tan x. Let's not be scared. Again, with enough practice and patience, I think we can solve this. So someone said u sub, and I think that's probably the best thing we should try to do. So let's go ahead and make u equal to our entire denominator. So that's going to be root tan x. This is great, okay? But typically, you know, I don't want to get lost in taking the derivative of that u value. So I'm going to go ahead and square both sides and get that u squared is equal to tan x dx. I think that's a lot nicer in my opinion. And so now let's try it out. Now let's go ahead and take our derivative of both the left and the right side and get 2u du is equal to secant squared x dx. Okay, not bad. And now we can go ahead and divide the secant squared to the other side to get this value here. So now we have that dx is equal to 2u du over secant squared x. And we're going to go ahead and plug that into our integral that we have there on the left. So we have the integral of 1 over u times 2u du over secant squared x. Not bad. It looks like it's not that difficult. Those u's cancel out, which is really nice. The 2, we're just going to put it on the outside. It's in the numerator, so that's just going to become a 2. And now we're left with integral of du over secant squared x. Pay very close attention to this one, guys, because it looks nice. It looks like we're almost there, but that secant squared is in terms of x, and our integral is telling us that we need to integrate it in terms of u. So we need to rewrite this. How are we going to do that? We're going to use one of the Pythagorean identities that we should definitely have memorized, and that is 1 plus tan squared x is equal to secant squared x. And what we're going to do is we're going to go ahead and substitute that in for the sine squared. So now we have integral of du over 1 plus 1 plus tan squared x. But then again, this is still in terms of x, but we do know that u squared is equal to tan x. So I'm looking up on top over there. So if I square both sides, we're going to get that u to the 4th is equal to tan squared x. And now what we have is this amazing integral of du over 1 plus u to the 4th. And now we have something in terms of u. So that's great. Yeah, I agree. You know, looking at these, this is why you're here. You learn one technique and it makes all the difference. And now you're going to think of all these other integrals that you probably could have solved that you can square both sides. It's really neat, and I think it's extremely helpful. Once again, guys, here we are with the integral of du over 1 plus u to the 4th. How in the world can we even attempt this? It looks a little scary. It's not an arctan, or it possibly could be. We don't know. But how do we even attempt that? Why would I grow the square? Because our integral was in terms of du, and we had a tan squared on the bottom. And it was in terms of x. So I needed to change that in terms of u, and that's why I used the u squared is equal to tan x, therefore u to the 4th is equal to tan squared x. But here we are again with this integral of du over 1 plus u to the 4th. How can we solve that? Someone said natural log, and I think that might be a possibility. Yes, thank you, Daniel. And that's going to be, it's so funny. It doesn't make that big of a difference, but Daniel mentioned that I totally forgot to put the 2 on the outside. So I'm going to do that now. Let me just write the 2, and the 2. Okay, that actually might be a little helpful. No, maybe not so much. Okay. Yeah, so someone said, can you split them into 2 integrals? Here's what I'm going to try. This is the first time me trying this, but again, I just see different techniques. I saw 1 plus u to the 4th on here, and I'm going to rewrite this as this. So last week on the chat, someone said that there is a factor for 1 plus u to the 4th, and it's this: u squared minus 2 root u plus 1, u squared plus 2 root u plus 1. I believe that's the factored form. Someone said complete the square. We can try completing the square, but we still have that u to the 4th. It kind of becomes an issue. So Austin said partial fractions. That's kind of where I'm headed. I have 2 integral of du over u squared minus 2 root u plus 1 times u squared plus 2 root u plus 1. And I believe that works. I'm just double checking my work there. U plus... Can someone, I'm just going to multiply it out. This is what I saw someone mention. I don't think we could do trig sub, unfortunately, guys. I'm just going to double check that this actually multiplies out. So plus 2u squared u plus u squared minus 2u squared u minus 4u minus 2 root u plus u squared. Oh, that doesn't work out. Okay. I'm getting that it doesn't work out. That doesn't simplify out, unfortunately. So maybe that's not the correct factor. Okay, so going back to this, any other ideas on how we can factor this out? It looks like I tried to factor it out and that wasn't the case. So maybe I am not right when it comes to this one. Someone said trig subtangent, but can we actually use trig subtangent? Here's what's going to happen if we use trig subtangent. We have the integral. This will be or sorry, not the integral. We have our triangle. This is 1, or actually we can do it the other way. This is u squared, this is 1, and this is root 1 plus u to the fourth. You see how much of an issue that is? It doesn't quite work. Yeah, so again, kind of useless when it comes to this. But let me find the factor form plus x to the fourth minus or plus 1. Because again, someone had a really nice way of doing this, or at least I saw it online, and I think it works. I truly think it works, guys. Let me just try it out real quick. Yeah, so that U sub just not as helpful as we thought. I'm just looking for, aha, here we go. So this is the factored form that this becomes. This is just crazy the way this turns out. Okay, for the sake of not taking everyone's time, let me show you how this factors out. So it is a partial fraction. So I was actually on the right track. So going back to this, what they want to do is they want to do a partial fraction. But I want to definitely talk about other types of integrals. But this 1 over 1 plus u to the fourth is going to turn into this. X plus root 2 over 2 root 2. Well, actually, first let me go ahead and give you the partial let me give you the partial fraction, then what that's going to equal to. So this is 2 integral of du over u squared plus 2 root u plus 1, and then u squared minus root 2u plus 1. So it wasn't root u. I'm sorry, it was root 2. Okay, here we go. Root 2u plus 1, and then root 2 minus root 2u plus 1. So this is the factored form here. Okay, this is a nice special factor for x to the fourth. So now what we're going to be able to do is we can use partial fractions. I don't want to do all that work because I want to talk about other integrals, but this is going to become 2 times, and now we have this nice partial fraction. This is x plus root 2 over 2 root 2 times, not x, u, and then now we have u squared plus root 2 u plus 1 du. And then we have the other one, plus 2 integral of negative x plus root 2 over 2 root 2 u squared minus root 2 u plus 1. And that's just a negative u. So as you can see, how that becomes extremely complicated. This now we can solve using completing the square if you wanted to, or it's going to be some sort of, there's 2 partial fractions within it. So if you like, I can continue solving this part of the integral, or we can try to solve other integrals. I can see that a lot of people left the chat because it's definitely time consuming. It could be quite boring at this point when it comes to that integral. So let me know in the chat, should I continue trying to solve that integral here, or should I move on to a different one? Okay, so I'm getting a mix of continue. Okay, and I maybe mean by continue, I mean move on to the next one or try to solve this. Sorry. Continue means I'm going to continue solving this integral here, but I'm moving on. It will be to solve another problem there. That was worded bad. Okay, so someone said continue solving. Okay, so let's go ahead and continue solving this. First thing that we're going to go ahead and do is this 2 root 2 that we have here in the denominator. I'm going to move it on the outside. So what's going to happen is the 2 and the 2 there are going to cancel out. So now what we have is we have 1 over root 2 integral of u plus root 2 over u squared plus 2 root, or root 2u plus 1. Okay. du. And then again, for this second integral, I can go ahead and remove the 2 root 2 from the bottom, and that's going to become plus 1 over root 2. And now we have negative u plus root 2 over u squared minus root 2u plus 1. Oh my goodness. Okay. So we're gonna have to go ahead and create some space on the blackboard. And by the way, I know that we're I wouldn't say we're getting sidetracked here. We are doing a more difficult problem than expected. But just so you know, I do have a free webinar that I'm doing this Friday. So if you guys are willing to join or want to join, the link is in my profile. Go ahead and visit that. It's a free webinar, and we can just go over more techniques over Zoom. Okay, so let's go ahead and talk about this first integral here. We can go ahead and use u sub, okay? But I want you to think about this, all right? We gotta kind of prepare because this is gonna get a little messy. I want to prepare by making this my u sub, which is totally okay. But we're gonna run into some issue here because if I make that my u, I'm gonna have to take the derivative of this, which is 2u plus root 2, but you're going to see that that doesn't cancel out with these things here. Okay? So before I even do u substitution, I'm looking at 2u plus root 2 because that was the derivative of the bottom value. I kind of want to have the same thing up here. Okay? So the way that's going to work is this. Looking at my numerator, I'm going to multiply the entire thing by 2. Bear with me here. And I'm going to subtract a root 2 and add a root 2 to both. So all that did is I multiplied everything by 2 and then I added those together. Hopefully that worked out. Okay. So one in the chat, let me know if that is okay. Again, I multiplied these two by 2 there, and then all I did was just add these, subtracted a root 2 and added a root 2. Maybe the algebra is wrong there. Yeah, maybe that's not going to be the best thing. But let me just kind of break this down. I'm trying to do some shortcuts here, but let me go ahead and actually, no, I guess we can keep it like this. Okay, so just give me 1 sec. Oh, no. Didn't want that. There we go. I accidentally moved stuff on my Zoom when I should have done it on my iPad. So again, I'm trying to get 2u plus root 2 on here. So then what I'm going to do, before I even do anything, check this out. All right, on my numerator, I'm going to multiply everything by 2. And that means that I'm going to divide by 2. So again, I multiplied by 2 and then divide by 2. What that does is that gives me 1 over 2 root 2 integral of 2u plus 2 root 2 all over u squared plus root 2 u plus 1. And this is good because I'm very close to having that derivative from the bottom. But then what I'm going to do is I'm going to have to go ahead and introduce minus root 2 plus root 2. All I did, that balances the equation out because this is technically 0 and we still have the same equation. But the reason why I'm doing that is because these two in the middle are going to be able to combine. So now I have an integral that looks like this. 1 over 2 root 2 integral of 2u plus root 2 over u squared plus root 2u plus 1. Whoops. And then I still have the other one. So I combine these two, but then I still have that other one that's on the outside. So that's going to be plus root 2 over u squared plus root 2u plus 1 du. This right here is this is still that first integral. That one is really simple because that is just the u sub. So this becomes 1 over 2 root 2 natural log of u squared plus root 2u plus 1. Again, for that integral there, all I did was I did u substitution. That was my u. The derivative was on top, so everything cancels out. And over here, I still have an integral that I got to take care of. But that, I'm just going to solve using completing the square. That's going to be plus root 2 over, and I have to complete the square there. So that's going to be u squared plus root 2u. I have to divide by 2 and then square it. So that's going to be plus 1/2. And the reason why that's 1/2 is because, again, I divided root 2 by 2 and then I squared it. So that became 2/4, which becomes 1/2. And then I still have the plus 1 minus, I need to subtract the 1/2 that I'm introducing. Okay, let's go ahead and make some space on the blackboard. As you can see, this is already becoming quite difficult. This is just the first part of the integral. Let me make this a little smaller so you guys can actually see what's going on. And so now what we have is we have 1 over 2 root 2, and then times natural log of u squared plus root 2u plus 1, and then plus integral of root 2 over u plus root 2 over 2 squared. I believe that's what it was. Yep. And then plus 1/2 du. Can you guys guess what that integral or how we're going to solve that? What method we need to use? I agree that Calc 2 is probably a lot harder than Calc 3. This is going to be an arctangent, by the way. So let's go ahead and do that. We still have 1 over 2 root 2 natural log of u squared plus root 2u plus 1, and then plus, I still need to do 1 over root 2 over 2. Or actually, I guess I can do root 2 times root 2 over 2. So that's all going to cancel out. Arctan of u plus root 2 over 2 all over root 2 over 2. That's just the first integral, guys. That's just the first one. I still need to take care of that second one over here. Let me go ahead and color it in blue. I need to take care of this one. So what do you think? Should I continue, or do we kind of get the idea and I can move on and do another problem? Continue solving it, continue solving that second integral, or do another problem. Totally up to you guys. Let me know in the chat what you think. Sure, you can go ahead and ask. Okay, someone said move on, please. Okay. And I don't have these memorized. I have the arctan memorized. That's pretty much it. Yes, next one. It's funny. I believe, wait, was it Valentina that suggested this? Someone suggested this. Yeah, I think people that saw this are probably like, okay, yeah, I give up. Let's go ahead and do another one. Yeah, this is just insane. It's you can do it, but it's definitely difficult. I think the hardest part is when you have the 1 over 1 plus u to the 4th. That's the hardest part in my opinion. All right, let's go ahead and try a different one. Let's kind of, let our brains kind of rewire again and kind of feel at ease. Let's go ahead and do this one. X cubed over x plus 1 dx. And someone said if they had Calc 3 questions, I'll sketch some flow lines. Oh, come on now. This is an integral, integration bee live. We can probably do that later on. However, you could go on my Discord. The link is in my bio, and there's a lot of people that are willing to talk math if you're interested. All right, guys, kind of just like if you're, a basketball player just can't get their jump shot right, they go to the free throw line and, they continue practicing some free throws to kind of get their jump shot back in order. That's what we're going to do here. We kind of had our brains go all over the place, but now we have this beautiful x cubed over x plus 1. Looking at this, who can suggest what we can do? And just so you know, if you need to leave, I do post the replays on YouTube for you to enjoy. Someone said plus 1 and minus 1. I'm curious what you mean by that. Plus 1 and minus 1. Someone said long division. Brandon, yes. Brandon, I think, Christian, yep, we're going to get rid of that x cubed. And Brandon, the way we're going to do it is long division. That's what Brandon said, and I completely agree. Here's the thing, guys. Whenever the degree of the top is larger than the bottom, go ahead and simplify that by first doing long division, and then we can do u sub what JH is going to suggest. Now, I'm going to do the long division, or I can do synthetic. I'm going to do synthetic. The only reason is because on the bottom I have an x plus 1. I could just put a minus 1 here and then put the coefficients for x cubed on the top. So this is 1 for my x cubed, 0 for my x squared, 0 for my x, and then 0 for my constant. I'm just going to call that c. And now let's go ahead and bring the 1 down. And now we have -1, bring that down. Now we have 1, bring that down. And now we have -1, bring that down. And we have -1. So then this integral can now be rewritten as x squared minus x plus 1 minus, and then the remainder 1 over x plus 1 dx. Beautiful. Again, numerator had a larger degree than the bottom. We go ahead and use long division. In this case, I did synthetic. Oh, I see. Yeah, different ways of describing it. Okay, I see. I understand the plus 1 minus 1 now. So looking at this, we're going to go ahead and just use u sub. So now we have, or not u sub, I'm sorry. The first one is just power rule, x cubed over 3 minus x squared over 2 plus x minus, and we still have that integral 1 over x plus 1 dx. That's going to be a u sub. Let me just quickly do it if someone just doesn't quite understand what I meant by u sub. U is equal to x plus 1, du is equal to dx. So now we have x cubed over 3 minus x squared plus 2 plus x minus integral of 1 over u du. So that's just going to be a beautiful and perfect natural log. I substituted the x plus 1 back, and now we have our plus c. Much easier, right, guys? Much, much easier. Yes, Henry, thank you. A natural log of x plus 1. Okay, I'm going to go ahead and erase this, and I'm going to write a different problem. While you're at it, double tap that screen. Don't forget to follow me on here. Follow me on Instagram or YouTube. And, of course, I am doing a free 1-hour webinar on Friday on integration techniques. The link is in my bio, so you guys can sign up if you like. So I have the integral of 2 over 1 plus cosine of 2x dx. After the tan madness, yes, someone is always trying to be, a maverick here and giving such a difficult integration problem that takes up 10-15 minutes and everyone just leaves. But here we are, guys. Yeah, that tan integral was insane. Yeah, there's a good amount. There's like the cubic root of tan. There's some tricks that you should definitely know when it comes to those. Anyway, looking at this integral here, if you guys have any suggestions, I am all ears. The arc length from 1 to 2. Okay. I'm assuming that's going to be a vector function, right? If that's the case, I'll try to do that in a second. If I think I know what you're talking about, I'll set that up. All right, again, any suggestions on 2 over 1 plus cosine of 2x? What can we do here? I think I have a method, but I don't know if I want to try it just yet. Let's try some stuff. Again, I don't know. There's a specific way of doing this using a different type of an identity. Yeah, someone said, is there an identity? I feel like there should be, right? Let's go ahead and rewrite the cosine of 2x. Maybe, again, I don't know. Let's perhaps do 2 over 1 plus. Cosine of 2x is a double angle, so like we can do cosine squared x minus sine squared x. I don't know if that really helps. Let's see. This becomes 2 over 1 plus 1 minus 2 cosine squared x. Maybe this is going to work. Okay, all I did was I rewrote that sine squared x as 1 minus cosine squared x. Oh, so that's actually going to be something different. Never mind. So I rewrote that sine squared as 1 minus cosine. So that leaves me with 1 plus cosine squared x minus 1 minus cosine squared x. So now we have 2 over Well, does that cancel out? No. 1 plus cosine squared x minus 1 plus cosine squared x dx. Oh, okay. If you notice, the 1's cancel out. So we're left with 2 over 2 cosine squared x. And what do you know? Those 2's cancel out. So now we're left with just the integral of 1 over cosine squared x dx. Aha. Okay, as I shrink this, or as I make this a little smaller, go ahead and let me know in the chat what comes next. How do we integrate 1 over cosine squared x? Someone said we write that into secant squared x, and I completely agree. That's another trig identity that we should memorize, or we should have memorized, I would say. So this becomes secant squared x dx. And what is the integral of that? Yes, the very last step is to go ahead and turn that into a tan x plus c. Boom. That's it. That is it. 1 minus 2. Oh, we could have. Yeah, I see. Yeah. So someone mentioned rejets. You had mentioned, why can't we simplify? I'll highlight it here in blue. Turn this into just cosine squared x. And so now we're just going to have cosine squared x plus cosine squared x. So you will skip these 2 lines and just get to this one. You're totally right. You absolutely can do that for some reason. Honestly, I just didn't see it. I was just thinking of the double angle formula. And I was just trying to rewrite the cosine 2x into a double angle formula involving cosine. But yes, you are absolutely right that we can solve it that way. Your method would have worked. All right. Very quickly, someone said that they wanted to find the arc length of a specific function. It's still integral, so I think it's still doable. This is the function. It is... So this is t squared. And then it's from 1 to 2. Well, if you recall the arc length equation, especially for vector functions here, the arc length is equal to the integral from a to b of root, and now we have dx over dt squared plus dy over dt squared plus dz over dt squared. And then the whole thing is dt. So if that's the case, we're going to take the integral from 1 to 2, root dx is the derivative of the x function, so that's going to be 1, so this is 1 squared, plus dy dt, that's the derivative of the y function, so that's 1 squared, plus dz dt, so the derivative of t squared, which is 2t, but we're going to square that. Oh, I think I already know where this is headed. And so now what we have is we have the integral from 1 to 2 of 1 squared plus 1 squared, that's just 2, plus 2t squared, that's going to be 4t squared dt. Okay, so let's go ahead and make this a little smaller. Arturo, nice to see you, dude. X squared minus x minus 1. I'll bring that up in a second. I'll probably do another one and then do that one in particular. Though if you do have to leave, Arturo, don't forget, the numerator has a larger degree than the denominator, so we can use long division. All right, now that we have this integral, any suggestions on how we can solve this? I can start simplifying it a little bit, but I can definitely try to do it differently before trying to simplify or factor anything out. This is a nice one. It's just root 2 plus 4t squared. I mean, why not just use trig sub? Let me go ahead and draw out the triangle that we want here. Okay, so we want, let's go ahead and do 4t, or not 4t, let's do 2t, because we need to square that. And on the bottom, we have root 2 as our adjacent, and now we have root 2 plus 4t squared for our hypotenuse. It's definitely trig sub. And so now what we have is we have sine, not sine yet, tan of theta is equal to 2t over root 2. So that's, remember, opposite over adjacent. Move the root 2 to the other side, so we have root 2 tan theta is equal to 2t. And now we can take, or actually, let's divide the 2 at the same time. Let's divide the 2 there. And now we can go ahead and take the derivative of this. So we have root 2 over 2 secant squared theta is equal to dt. Not bad. But then we need to find an equation for the root, or for the square root, the hypotenuse there. And the way we're going to do that is we are going to say that secant theta is equal to root 2 plus 4t squared over root 2. In other words, root 2 secant theta is equal to root 2 plus 4t squared. Okay, let's go ahead and make this a little smaller. And let's continue talking about how we're going to solve that. Okay, let's go ahead and, again, this is still arc length. So this is equal to the integral. We'll change our parameters in a second because one was in terms of t. We don't want that. We need it to be in terms of d theta now. So our first point or order that we need to do here is we need to rewrite this square root. And if you recall, that square root is 2 secant squared, or root 2 secant theta, I'm sorry. So this is root 2 secant theta times dx, or dt in this case. dt is this part. So we have root 2 over 2 secant squared theta d theta. And so now we need to rewrite our stuff in terms of our parameters in terms of theta, because I don't want to plug it back into t. Now, how are we going to do that? Well, if we look for the 1, that's for the value of t. So let's go ahead and focus on our tangent. Because when t is equal to 1, that means that tangent theta is equal to 2 times 1, which is 2 over root 2. And in other words, that's root 2 over 2. Ugh. And I don't think we have anything for that. Root 2 over 2. We don't. Okay, never mind. And we're just going to have to rewrite this in terms of tan after. Anyway, so let's not write any parameters. We'll write it at the end. I thought it was going to be easier than that, so we're not going to do that just yet. So let's go ahead and first just combine these constants. Root 2 times root 2 over 2, that's just going to be 1. So we have integral of secant cubed theta d theta. Oh, boy. We need to know this integral here. And it's actually quite easy. It's 1/2 natural log of secant theta plus tan theta minus, oh my goodness, I think I forgot it. Is the next one secant theta tan theta? This is one of the basic integrals that we should remember. It's funny, I know all the other ones, but not secant cubed. But it's all right. We can definitely review how to find that one, but it's going to be a whole extra step. But you should definitely know it. That's for sure. So let's go ahead and it is this one. It is not ln. I knew it. So it's just 1/2 secant theta tan theta minus, or plus 1/2, I'm sorry, natural log of secant theta plus tan theta plus c. Okay, so that's going to be our integral. Now our job is to rewrite this back in terms of t and then plug in your parameters for 1 and 2. Oh, so, okay. So I think it's time that let's go ahead and review the integral of secant cubed, because it's one that you should definitely know, but let's review. I think it's been a while since we've done it. So you mentioned that's where you're going to get stuck. Just keep in mind that's our answer. And then from there, you just go ahead and rewrite it in terms of t, and you plug in your parameters. But I'm going to go ahead and do the integral of secant cubed, just to review it with you math nerds. Let me go ahead and erase that. Okay, so keep this in mind. Hope you took a screenshot of this problem, because here we go. Whoops, secant cubed x dx. All right, so let's talk about how we're going to rewrite this. Okay, the first step that we're going to do is we're going to rewrite this, or we're going to use the reduction formula. I think that was one of the first things that someone mentioned on here. I'm trying to see. Yes, someone asked the reduction formula. That's exactly what we're going to do. We're going to rewrite this as secant squared x times secant x. That's going to be the first thing. Okay? Now, the reason why we're doing this is because we're going to use a u sub, or integration by parts. I'm sorry. U is going to equal to secant x. du is going to equal to secant x tan x dx. And our dv is going to be secant squared x dx, so that our v is just tan x. And so now what we have is we have the ultraviolet voodoo, uv minus integral v du. So our uv, secant tan, so we have secant x tan x minus integral of v du. So tan x times secant x tan x dx. All right. And keep in mind, this is still equal to, this is supposed to equal to secant cubed x dx. And so now let's just kind of rewrite this just a tiny bit. We have the tan squared, or the tan x times the tan x here. So I'm going to rewrite that. So we have secant x tan x minus integral of tan squared x. And then we have secant x. Yeah, just tan squared x and then secant x. And don't forget, this is still just equal to secant cubed x dx. All right, from here, who can tell me what else we could do? Because it looks like we have the secant x, which is great, but then we still have this part, which is kind of frustrating. Wouldn't you say? Well, check this out. We're going to rewrite this. We're going to rewrite the tangent as secant squared x minus 1 secant x. Now, why did I do that? Because that was a trig identity. 1 plus tan squared is equal to secant squared x. So I just brought the 1 to the other side to get secant squared x minus 1. And now what we have, again, don't forget that this is going to be the integral of secant cubed x. Now let's go ahead and distribute the secant cubed. And look what we have. Secant x tan x minus integral of secant cubed x minus secant x dx. Now this is where we got to be really careful with our parentheses. Let's go ahead and make this a little smaller, and hopefully from there you guys can kind of already see where we're headed. Okay, one thing that we have to be very careful with is that we still have that negative sign, but that's going to be distributed to both of these terms in the integral. So then what we have is we have secant x tan x minus integral of secant cubed x dx plus integral of secant x dx. And now what we can do is I'm going to do 2 steps. Bring this to the other side. So I'm just going to add that integral to the other side. So you're going to have 2 of them on the right side. And then I'm going to take the integral of secant x. So now we have secant x tan x plus natural log of secant x plus tan x. That was the integral of secant x plus c is equal to 2 integral of secant cubed x dx. And then our final step is just to go ahead and divide the 2 to the other side. So everything just has a 1/2, or I can just leave it as divided by 2. That is the integral of secant cubed x. Hopefully that makes sense to a lot of you. Yeah, it's pretty neat. One of the ones that we should definitely keep it or memorize, I would say. Okay, so now Arturo said, can we do this specific integral? If you notice, this is one that we had just done, or very similar to it. Arturo, x squared over x minus 1 dx. I'm going to do this one very quickly. If you recall, you have the degree of the top is greater than the bottom, so we're going to go ahead and use long division. But in this case, I'm just going to do synthetic because it's an x minus 1. It's a binomial, or a binomial of degree 1 on the bottom. So we have 1, and then we have 1, 0, 0 for our terms. This is for the x squared, this is for the x, this is for the constant. So you bring the 1 down, you get 1, and then you bring the 1 down again, you get 1, you get 1. So this is just going to become x plus 1 over x minus 1 dx. That first integral is just x squared over 2 plus x plus, this is a simple natural log, so we have natural log of x minus 1 plus c. Awesome. There we go. All right. I have some more integrals that we can do. I think maybe we have time for possibly 2 more, but does anyone have other suggestions? Something that they've seen in class or something that they're confused on? I am ready to fail at any problems that you guys give me or not. Who knows? But I do have one here. Let's go ahead and try this one. Let's do integral of root x squared plus x to the fourth dx. Tan of 7, the 7th power of x dx. Oh, okay. I don't know how far I can get to that one. However, let's call this integral 1. And then you said tan of the root 7th x dx. All right, guys, so let me know in the chat. Should we do 1, number 2, blue, or red? What do we think? Adam suggested this. I don't even know if I know the answer to that, to be honest. Someone said, oh, geez, okay. You guys are going to be disappointed. Someone said 2. Still looks like it's going to be 2. Okay. Let's try it out then. Let's go ahead and try the integral of tan to the 7th power. Adam, did you make that up? We'll be done with number 2 by tomorrow. I think so too. Let's just try it out. Okay. Well, let's go ahead and try tan to the 7th power of x dx. Now, actually, I don't even know if that's going to be as difficult as I'm making it out to be. I don't know. But let's try it out. Okay. When it comes to these, you kind of want to leave some. Okay, let's try a few things. Again, I'm just thinking. I don't know how to solve this, but I'm just going to think about it. And if we fail, then we fail, and then we'll call it a day. But this is the whole point of integration. It's just practicing as much as you can. I'm thinking of rewriting this as tan x times tan to the 6th x. I don't know how helpful that's going to be. I don't think it's helpful at all. However, okay, let's go ahead and rewrite this as sine to the 7th power over cosine to the 7th power dx. Perhaps this can work. I don't know. Okay, and if you guys have any suggestions, please let me know. Because I am just trying different things, and maybe I'm giving up as I'm going along with one method. But I can rewrite this as sine to the 7th x over, maybe I can do cosine squared x times, no. Yeah, multiplication of powers, that's what I'm thinking. I'm trying to rewrite this, but perhaps I'm just making it more difficult on myself. But let's try this. I mean, what this is, oh, you know what? Perhaps this could be it. I can rewrite this as tan squared x times tan to the 5th x. I still don't know how helpful that's going to be. To the dx. And then I'm trying to rewrite this as 1 secant or something like that. 1 plus secant squared. Okay, well, let me just rewrite this as 1 plus secant squared x. Or no, this wasn't 1 plus secant squared x. I'm sorry. This is secant squared x minus 1. And now I'm just going to multiply this a little bit. So now I'm going to have secant squared x times tan to the 5th x minus tan to the 5th x dx. And I think that's where we're probably going to have some issues. So time sine to the 3x. Okay, I'll try that one MK in a second. Because I think that's where I'm going to have it. Oh, and that's kind of where we're headed with that one. Okay. Well, so for this one, again, I split these up. And I believe I can solve the first integral here. That's just going to be u is tan x. So du is secant squared x dx. So that helps me out. because this is just going to be integral of u to the 5th du, which is u to the 6th over 6th, plus c, obviously, which we'll take care of in a second. So that fixes that part, and now I can continue reducing it as much as I can. Because now what I have is I have tangent of 6 to the 6th power over 6 minus integral of tan over 5x dx. And I'm going to add the plus c at the end, but let's not worry about that. And now MK was saying, let's go ahead and rewrite this. Maybe I can continue working, like chipping away at this. Perhaps I could. Because now what if I rewrite this tan 5th x as tan squared x times tan cubed x dx, and I rewrite that tan squared as secant squared x minus 1 tan cubed x dx. Oh, I think we're doing this. And maybe there's a shortcut to this. I think there's got to be. And maybe that's what MK was saying. I feel like there's got to be a shortcut to that. But I'm just going to continue with this process. Because now what I'm going to have is I have tan to the 6th x over 6 minus integral of secant squared x times tan cubed x plus tan cubed x dx. So what I did is I just multiplied the tan to both of these terms, and then I distributed the negative sign. So now I have two different integrals. This one we already know. It's kind of like the first one that we did. Our u is tan x. So we're just left with tan to the 6th x minus 6 over tan to the 4th x over 4. And then plus integral of tan cubed x dx. And I think I can split this up even further. And do tan squared x times tan x dx. Here we go, guys. Let's go ahead and make this smaller. Hopefully you can kind of start seeing a pattern, and I think we are going to be in the right direction. Because now what I have is I have tan to the 6th x over 6 minus tan to the 4th x over 4 plus integral of, I'm going to rewrite the tangent as secant squared minus 1. And I'm just going to go ahead and distribute the tan x. So now we have integral of secant squared x tan x minus tan x dx. Ah, this is beautiful because look, we can take the integral of that. Same thing, same process as the other two. This is tan to the 6th x over 6 minus tan to the 4th x over 4 plus tan to the 2nd x over 2. And now we can go ahead and take this last integral of tan x, which is just going to be minus natural log of cosine x. And then the whole thing plus c. Yo, amazing, amazing, amazing. Yeah, definitely like a reduction formula. So everyone here was on the right track. Nicely done. I'm going to look at this last one over here, Sebastian. Unfortunately, this was my last problem, but I'm going to leave it on the screen for other people to do it. And so that I can remember, I'll make a video of this for you. So I have x squared minus 1 over root 2x minus 1. This is interesting. Very interesting. Looks like a U subtype problem. I wonder if you can solve this using like Feynman technique. Yeah, there's got to be interesting ways of solving that. Now, I don't know how to do it, but I will probably start off on making u equal to the entire square root and then making u squared equal to 2x minus 1. I don't know. Curious about that. Okay, but anyway, I'm going to take a screenshot of this one because I definitely want to do it later on. But that was my last problem, the one that we just did, tan of 7x. So I think now we can kind of see a pattern with that. We can kind of continue working and chipping away if we did tan to the power of like 9x, 10 to the power of 11x, and so on. But yeah. Anyway, guys, that was it for today. Typically, Integration B Tuesdays, I have a list of problems, but people on the chat always like to do or bring up other integrals, which I think is kind of fun. And don't forget that I'm going to be here Thursday for math survival skills and we are going to continue reviewing AP Calc problems. I know the AP exam's coming up in May, so I definitely want to start reviewing for those things. And don't forget that I do have a free webinar for Friday that you guys are welcome to join. All the descriptions and all that good stuff is in my bio. Anyway, guys, I'm going to take off. I hope you guys have an amazing rest of your Tuesday. Hopefully you're here on Thursday, but if not, catch the replay on YouTube. All right, everyone, have a great day. I'll talk to you soon.